Hello students, today we will discuss chapter 13, Motion and Time. What do you understand by motion? When an object changes its position with time, we often perceive an object to be in motion. For example, when the position of the car changes with time, we say that the car is moving or the car is in motion. Now there are different types of motion like rectilinear motion, circular motion. Rectilinear motion means the motion possessed by the body moving along a straight line. That is known as rectilinear motion. And circular motion is the motion possessed by the body when it moves along the circular path. So this is the central path. Along this circular path, when the body moves, that is called the circular motion. And when the body moves in the linear fashion or along a straight line, that it is called rectilinear motion. Example of circular motion is the motion of the child in merry-go-round, the motion of the earth around the sun. Next is rotational motion, the motion of the body when it moves around a fixed axis. For example, this is the earth and it moves around a fixed axis, that is called rotational motion. The motion of the earth about its own axis, or your favorite one, that is spinning top. The motion of the blades of a fan around the fixed axis. Periodic motion, the motion which repeats itself at a regular interval of time, is called periodic motion. The motion of swing, to and fro motion of the simple pendulum, all these are the example of periodic motion. Now there may be slow motions and fast motions. For example, an object when it takes a long time to cover a certain distance, it is known to be having slow motion, while the other object which takes shorter time to cover the same distance is said to be having fast motion. So it all depends upon the distance and the time covered. Now this flow chart is very nice to give you the brief account of types of motion. First is random motion. The motion having no specific path is known as random motion. For example, the motion of the butterfly, because it does not have any specific path. Then translational motion, further, because translation motion is basically divided into two, rectilinear and curvilinear. The motion in which all particles of a moving body describes identical trajectory. So that is translational, or we can say translation motion is further having two category, that is rectilinear and curvilinear motion. Rotational motion we have already discussed, motion in a circular path, and oscillatory motion is fast to and fro motion is oscillatory motion. So motion which is to and fro, that is called oscillatory motion, and fast oscillatory motion is vibrational motion. So that is not there, but oscillation is to and fro motion. For example, this girl is sitting on the swing and the swing is moving to and fro. So that motion is known as oscillatory motion. So these all are the types of motions. Now further we have got uniform and non-uniform motion. Uniform motion means an object is said to be in uniform motion if it covers equal distance in equal interval of time. For example, this is your graph. This is on x-axis and on y-axis. Generally or usually on x-axis we keep the time and on y-axis we keep the distance. So an object is said to be in uniform motion if it covers equal distance at equal interval of time. And on the same hand, you can see on the other hand, an non-uniform motion is an object is said to be in non-uniform motion if it covers unequal distance in equal interval of time. Time will be equal, but the distance covered will be unequal here in case of non-uniform motion. So time will be equal always, and it will be kept on x-axis, and on y-axis while plotting the graph we will keep the distance. The difference between uniform motion and non-uniform motion will be clear to you with the help of this this slide, which clearly shows the difference between uniform and non-uniform motion. This is the graph where you can understand in case of non-uniform motion, you don't get the straight line here, but in case of uniform motion we get a straight line, because it is the distance covered by the body, equal distance covered in equal interval of time, but this one is unequal distance covered in equal interval of time. The time interval we have to keep equal in both, but in non-uniform motion the distance covered will be unequal and here it will be equal. Now the unit of speed is, SI unit of speed is meter per second. For that, speed is equal to distance upon time, we know. So what is the SI unit of distance? That is meter, and for time it is second. So we can write meter per second this way also, or meter per second this way also. So this will be the SI unit of speed. Either way you can write. If you feel like to write like this or like this, your choice. The unit of speed is meter per second. Now this slide will give you relationships which you are already aware of. 1 day, 24 hours, 1 month, 30 days, 1 year, 12 months. 1 hour has 60 minutes, 1 minute, 60 seconds. The larger units of time are minutes and hour, but SI unit of time will be your second. Now this slide is very good to understand the relationship. You have to learn this. Speed is equal to distance upon time. When you have to take out the distance, then it will be speed into time, and when you have to take out time, then it will be distance upon speed. Average speed will be total distance upon total time. And in previous slide, what will be the unit? Because whenever you solve the numerical, you take out the value. After value, don't forget to write the unit, and here unit will be meter per second. Here distance is measured in meter, time is measured in second. You can write like this, or meter per second like this also. Now there are various ways of measurement of time. A duration or moment in which things occur is known as time. With the help of clocks and watches, we can measure time. So now there are various ways by which ancient people used to measure the time, like sundial, then water clocks were also there, then sand clocks were also there. So these are the various ways by which ancient people used to measure the time. Then next is simple pendulum. Simple pendulum consists of a small metal ball called bob, which is suspended by a long thread from rigid support such that bob is free to swing back and forth. The to and fro, back and forth means to and fro. The to and fro motion of a simple pendulum is the example of periodic motion, because this is the motion which repeats itself at a regular interval of time, or we can say oscillatory motion, because oscillatory motion is to and fro motion. And Galileo was the first person to study the motion of the pendulum. This is how it looks like. This is pendulum. With the help of pendulum, we can study periodic motion or oscillatory motion. Here it is very simple. It is having metal ball, that is bob, long thread and one support here. So this position, when bob moves to this position, this is called extreme position. This is also extreme position, and this fixed position is called mean position. So how it completes its one oscillation? It completes its one oscillation. For example, if you are moving the bob from this position, so just hold the bob from this position, extreme position, and just release it, and it will come back to the same position. It will be one oscillation. It will be counted as one oscillation. Simple pendulum completes every swing or every oscillation in exactly the same time, provided its length should be kept constant. If we will change the length, then it will increase or decrease. For example, if you increase the length, then time period will also increase. If you change the bob, its weight, the pendulum or the time period does not depend upon the weight of the bob. The pendulum also complete one oscillation when its bob moves from one extreme position D to another extreme position E and come back to the D. From wherever you start, the movement of the pendulum, it should come back to that position only. So the time taken by the pendulum to complete one oscillation is called time period. What is time period? Time period is time taken by the pendulum to complete one oscillation, and you should know how to calculate one oscillation. So with the help of this pendulum, we have to calculate the time period. And what is time period? Time taken by the pendulum to complete one oscillation. So for that, it's very difficult to keep track of one oscillation. So we will for example take 20 oscillation. So time taken in completing 20 oscillation will give you the time period of one oscillation. The time period of pendulum depends on its length. The length of pendulum is the length of thread from the point of suspension. If you can increase the thread length, the time period will also increase. Now we have got modern clocks nowadays, which has, for example, quartz clock. These are the modern clocks. The way we were having ancient clocks like sundial, then sand clock, water clock, same way. Nowadays we have got modern clocks, quartz clock or digital clocks. Now we have got speedometer. This is the instrument present in the vehicles to tell the speed of the vehicle, and odometer tells the distance covered by the vehicle. So this is how we plot the graph of uniform motion. Thank you very much. Revise well.